G'day, Mrs. Delgardno here. Hope you guys are doing well. I had a request for a chemistry class, so here it is. Bearing in mind, I am not a teacher, I am not a chemistry teacher. In fact, I have not done chemistry since high school, which for those of you who are going to be watching this video is before you were even born. Yeah, that's right. So basically what I did was I just YouTubed a couple of clips to refresh myself on my chemistry, and let's see how we go. So today we're doing stoichiometry, and I don't even know if that's actually how you say that. You should probably ask your chemistry teacher. But here's another free life tip. As an adult, if you say something fast enough and kind of mumble, no one's actually going to correct you. So that's what we're doing today. So we have a chemical reaction on the board. This is actually a really common chemical reaction, especially in the summer as you guys are starting up your barbecues. We have propane that's mixed with oxygen, and when it reacts completely, it makes carbon dioxide and water, okay? So as much as we look at this and we know that this is a true statement, propane and oxygen make carbon dioxide and water, this isn't an accurate statement. And here's what I mean by that. I really like making juices. I love putting lots of different juices in a blender and mixing things together. And if you asked me what do you like to put in your juices, I could tell you I like to put in pineapples and lemon. I have a pineapple and lemon base mixture, and then I'm going to add some ginger and it makes my juice. Now that's a correct statement, but it doesn't really help you, does it? Because you don't know how much of those ingredients are going to be reacting or mixing in this juice. So as much as this is correct, it needs to be balanced in order to be accurate so we can actually make some quantitative measurements of what we're talking about. So let's look at this and let's balance it together. We have 3 carbon atoms here, but we only have 1 carbon atom on this side. Now I know you can look at this and chemistry can feel like it's this nebulous thing out there, but remember we're talking about matter. This is actual stuff. Even though it's on a molecular level and atomic level that these elements are so tiny, it's still matter. I can't turn 3 pineapples and 8 lemons into an orange. It's going to be what it's going to be. I can't make 3 pineapples turn into 1 pineapple. I'm still going to have 3 pineapples. So we're using matter. If I have 3 carbon on this side, I have to have 3 carbon on another side. I am not God. I can't come up with matter and I can't make it disappear. I can only manipulate it. And even then, we're only manipulating these as far as their valence electrons are going to allow them. Obviously, you would have covered that in previous chemistry classes. Isn't that amazing? All of these valence electrons, and we can only manipulate matter in as far as God even created it for it to be manipulated in the first place. It's really incredible. Anyway, let's go back to balancing this equation. So 3 carbon, we've got to have 3 carbon on this side. We've got 8 hydrogen on this side. We have to end up with 8 hydrogen on this side. So we already have pairs. How many pairs are we going to need? We're going to need 4 pairs so that we now have 8 hydrogen on this side. How much oxygen have we ended up with? Well, we've got 4 oxygen in this particular molecule, and we have pairs here. We have 3 pairs, so 6 there. We're going to need to start with a total of 10 oxygen, and they're in pairs right now. So we need 5 of those pairs. Now we have a balanced equation. Let's put a 1 here because that's going to be helpful for us. Even as we look at this and you think about 1 propane molecule mixed with 5 oxygen molecules reacting completely is going to make 3 molecules of carbon dioxide and 4 molecules of water. Well, no one works on such a microscopic level. So what are we going to do with this? Well, let's think about it. What if we had 5 propane molecules? Well, then we'd have to use 25 oxygen molecules. Well, then we would get 15 carbon dioxide and we'd have 20 water, right? Well, what about if we had 100 propane molecules plus 5, we'd need 500 oxygen, sorry, zeros and O's get confusing, but you can follow along with me, would be 300 carbon dioxide and 400 water molecules. What about this? What if we had, I'm not going to get enough space, plus 5 times 6.0. You see what I'm doing here, right? This number should be familiar to you. We'll get there. I'm writing as fast as I can, guys. 6.022 times 10 to the 23 carbon dioxide plus 4 times 6.022 times 10 to the 23 water. Does this look familiar? Right, it's 1 mole. This is that avocado guy's number. Now, I don't remember. It sounds like avocado, so ask your chemistry teacher what his real name is, but it's the avocado guy, and I know you know what I'm talking about. But this is 1 mole. Now, 1 mole can be really confusing, but 1 mole is just a numerical unit. Think about it like you're talking about a dozen of something. Okay, if I have a dozen pineapples and a dozen apples, that just tells me the numerical value of how much of the matter I actually have. But it doesn't mean that 12 pineapples weighs the same as 12 apples or 12 lemons. Got it? So if you start thinking about 1 mole, just like you do a dozen of something, we have 1 mole of something. So looking at these coefficients, not only do these coefficients break down and show us on a molecular level exactly what's going on, it also gives us the ratio, as long as we're sticking within the ratio to which they're going to completely react. Let me rub this out and then we'll get started on next session. Okay, kind of part B. So we established earlier that not only do these coefficients tell us on a molecular level what's reacting and what it's going to produce, these coefficients also show us the ratio for which a complete reaction will occur. So now we want to use that to work out some quantitative measures of the products in this reaction. So let's say the example we're going to use is I have 25 grams of propane, C3H8, completely react with oxygen to produce how many grams of H2O? Now again, this might seem completely overwhelming, but there's a lot of things we do actually already know. We have the amount in grams of oxygen that we have. We have the ratios in which these molecules are going to react. And we're also going to use our molar mass, which we will look at our periodic table and the atomic masses, which you should have covered probably already in earlier chemistry. In fact, I would recommend on a high school level probably learning the first 20 elements, their relative ions, and then their atomic masses to probably the 3rd decimal off by heart. I'm not going to do that because I'm not in high school, so I don't need to know it. But you do. I'm just going to look at it online. Anyway, we'll get there. So 25 grams of propane. Here's, you know the formula. Here's how it has to go. Right, we're going from the grams of substance A to the moles of substance A to the moles of substance B to the grams of substance B. Okay, remembering that we can't just go, oh, well, if we have 1 mole of this and 3 moles of this, then we can use, like, if we have 25 grams of this, it means we have 3 times the amount of grams of that. Remember, that's not what a mole is talking about. That's not what these ratios are talking about. A dozen apples does not weigh the same as 3 dozen or a dozen of this, and so you times it by 3, because the molar ratios are simply looking at it like it's a dozen. We have the numerical figure of it, not how much it weighs. Okay, so we start with what we've got. What have we got? We've got 25 grams. Actually, I'm going to use my black pen for this. So we have 25 grams of propane. Okay? And we want to turn that into moles. So we need to look at what is the molecular mass of this. Well, let's go to our periodic tables. You can learn some of this stuff off by heart, but hang on a second. use my pen and paper. What have we got? We've got 3 carbon, and carbon is 12, I don't even know if you can still see me, 12.011, so times that by 3. And we've got 8 hydrogen, which is 1.008, and times that by 8, and that add them together. So let me get my phone. So 12.011 times 3 equals 36.033. Remember that? You got it? You got it? You know what? I'm going to write it down because I have the most terrible memory. 36.033. All right, and then we have 1.008 times 8 equals 8.064. So that's how many the weight of the hydrogen plus the 36.033, 44.097. Got that? 44.097. Right? The molecular mass of this in 1 mole of C3H8 of propane. Okay, so this is going to tell us if this is how many grams is 1 mole. From 25 grams, how many moles do we have, right? So that's going to tell us in 25 grams how many moles do we have. Let's continue on with our equation. We already know the ratio of the moles of propane to the moles of water. It's 1:4. Okay, on the top, you're always putting on the top what you want to go to, and you're putting on the bottom what you already have. So here we had 25 grams of propane. That's what we have here. And then we put that on the, excuse me, the bottom, the grams on the bottom, right? And we're going to moles. So now we're wanting to go to moles of B. So we have moles of A, how many? What's the ratio? 1. 1 mole of C3H8 is to 4 moles of H2O. Okay, we continue on with our equation. These are going to equal out. Okay, the last thing we need to look at, this is really hard work. It's after my kid's bedtime, which means my brain is like toast, but I'm doing this for you. I'm doing this for you. Okay, so now we're going to look at the mass of water, right? So let's look at our periodic table again. What am I looking at? So we've got 2 hydrogen, so 1.008 times 2, which you should be able to do in your head, plus oxygen, which is 15.999. Trusty dusty, handy dandy, calculate that, times 2 plus 15.999 equals 18.015. Okay, so what am I doing? 18.015 of grams of H2O per 1 mole of H2O. Moles of H2O, moles of H2O. Okay, so now our equation is ready to just plug the numbers. So let's do that. We have 25 divided by 44.097 times 4 times 18.015 equals 40.853. And I would just be taking everything like it shows on your periodic table to the 3rd decimal point. So 40.853 grams of H2O, right?